So the question is explain briefly the wireless sensor networks, which is asked for 6 marks in Jan-Feb 2023. So we have to short the answer for 6 marks. So I have made a overall picture of the topic. So we have 5 main points, starting off with the definition, limitations of smart objects in WSN. Then we have the design constraints for wireless smart objects with a diagram, then data aggregation in WSN with an example, and finally communication protocols for WSN. Okay. So the first point is that the wireless sensor networks are made up of wirelessly connected smart objects, which are sometimes referred to as modes. So what is meant by this modes? This single node in the wireless sensor networks are often referred to as the modes. Okay. So wireless sensor networks are made up of wirelessly connected smart objects, which are sometimes. So these wirelessly connected smart objects are called as modes. Okay, so what are the limitations of the smart objects in WSN? So the first limitation is limited processing power. Second limitation is limited memory. Then third limitation is lossy communication. Fourth one, limited transmission speeds. And fifth one, limited power. Now moving on to the design constraints for wireless smart objects. So we have 5 design constraints: moderate CPU power, low memory, lossy communication with narrowband media, and power consumption is very critical. So these are the 5 design constraints for wireless smart objects. So moving on to the data aggregation in WSN. So data aggregation, instead of using one single sensor, since it is inaccurate, we connect a lot of the redundant sensors and we take an aggregation of all the readings from all the sensors. That is called as data aggregation in WSN. Okay. So the first point is smart objects with limited processing memory, then power, and so on are often referred to as the constraint nodes. These limitations greatly influence on how the WSN are designed, deployed, and utilized. The fact that individual sensor nodes are typically so limited is a reason that they are often deployed in very large numbers. As the cost of the sensor nodes continue to decline, the ability to deploy highly redundant sensors becomes increasingly feasible, right? Because the cost is declining. Because many sensors are very inexpensive and correspondingly inaccurate, the ability to deploy smart objects redundantly allows for increased accuracy also. Such large number of sensors permit the introduction of hierarchies of smart objects. Such hierarchy provides, among other organizational advantages, the ability to aggregate similar sensor readings from sensor nodes that are in close proximity to each other. Now, in the next slide, we have a figure that shows an example of data aggregation function in WSN, where the temperature readings from a logical grouping of temperature sensors are aggregated as an average temperature reading. Now look at this diagram. What we have is data aggregation in wireless sensor network, where we are taking temperature readings from many sensor nodes: 11.5, then 12.1 degree centigrade, 11.8 degree centigrade, 11.3, 12.2, and 11.7. Then we are calculating, taking an aggregation of all the values. We get average temperature. We are taking it as 11.7 degrees centigrade. This is one of the example of data aggregation. These data aggregation techniques are helpful in reducing the amount of overall traffic in WSN with large numbers of deployed smart objects. Wirelessly connected smart objects generally have one of the following two communication pattern. Now we are concentrating on the communication pattern of the smart objects. So we have two communication pattern. One is called as event driven and the second one is periodic. So by name itself gives you the meaning, right? Event driven, only at particular time. Periodic means, so let us see. Event-driven transmission of sensory information is triggered only when a smart object detects a particular event or predetermined threshold. But whereas periodic means transmission of sensory information occurs only at periodic intervals. Okay. The decision of which of these communication schemes is used depends greatly on the specific application. For example, we are taking the medical use cases. Say for example, in some medical use cases, sensors periodically send post-operative vitals such as temperature or blood pressure readings, but whereas in other medical use cases, the same blood pressure or temperature readings are triggered to be sent only when certain critically low or high readings are measured. Okay, and now we are going for the last topic, that is your communication protocols for wireless sensor networks. What are the requirements? There are literally thousands of different types of sensors and actuators. WSN are becoming increasingly heterogeneous with more sophisticated interactions. Any communication protocol must be able to scale to large number of nodes. Yes or no? Yeah, it's true. Right. Any communication protocol, the main property it should be the scalability, ability to scale to a large number of nodes. When selecting a communication protocol, the requirements of the specific application must be taken into account and consider any trade-off the communication protocol offers between the power consumption, maximum transmission speed, range, tolerance for packet loss, topology optimization, security, and so on. They must also enable as needed the overlay of autonomous techniques, for example, self-organization, self-healing, self-configuration, etc. Wireless sensor networks interact with their environment, right? Sensors often produce large amounts of sensing and measurement data that needs to be processed. This data can be processed locally by the nodes of a WSN or across zero or more hierarchical levels in IoT networks. Communication protocols need to facilitate routing and message handling for this data flow between the sensor node as well as from the sensor node to the optional gateway, edge compute, or centralized cloud compute, right? So communication protocol is mainly necessary for the transmission of the data, right? Standardization of communication protocol is a complicated task. While there isn't a single protocol solution, till now there is no single protocol solution. There is beginning to be some clear market convergence around several key communication protocols. So these are the important points which you can write for 6 marks for wireless sensor network.